So let us continue with our exercise 10.2. Question number 9 onward we have to discuss today. In question number 9, you read the problem very carefully. You are given with three tangents there. One is xy, x dash, y dash are the two parallel tangents, and third tangent is AB. These two touches the circle at P and Q, and POQ is the diameter as O is the center here. And third tangent AB touches the circle at C, OB and OA are joined, and then we need to prove this angle AOB so formed is equal to 90 degree. So write the information, what is given and what is to prove. In construction you can join this O with C. Now we are focused upon this figure and we have to find out this angle AOB somewhere with the properties. Properties, as I already told that onwards question number 8, we are applying the second theorem we did there. The tangents drawn from the point lying outside the circle are equal or equally inclined and make equal angle with the line of joining the center. All those three parts you need to recall. So here, when you will be studying this triangle, that is your OAP and OAC. Here it is OAP and OAC. You look at this. A is the point lying outside the circle, and from A, AP and AC you can see are the tangents. So definitely AP I can write is equal to AC. OA is equal to a common, and OP and OC are the two radii there. So if I am using this information I have written here, this is common, these are the radii, and these AP. Why AP is equal to AC? Because these two are the tangents from the common point to the circle lying outside the circle are always equal. So I can use the congruency SSS, and then my angle 3 is equal to 4. Otherwise also angle 3 is equal to 4 because the line here in the center is inclined equally. These two angles are equal, angles 3 and 4. And then similarly your 1 and 2 will also be equal. And then what you can do is PAB and QBA. Now you have this angle PAB and QBA. Somewhere if you see these are the two parallel lines and this is the transversal, so the sum of the angles to the same side, one is at B and one is at A, are co-interior angles. So that property you can use here. So PAB, if you see, is the twice of angle 4 because 3 is equal to 4, or your angle QB is twice of angle 2 I can say. So then it is equal to 180 degree, then I am getting 4 plus 2 is equal to 90 degree. So now in this triangle OBA, I am getting the sum of these two angles, 2 and 4 is equal to 90 degree. So then definitely the third angle automatically will be of 90 degree. As you know, all the sum of the three angles of a triangle is 180 degree. So that property you can use. So you will be reaching at your destination, that is how to prove angle AOB is equal to 90 degree. So that's all about your question number 9. This is an important question from the examination point of view. Frequently the question is coming in your examinations. Then question number 10. So in question number 10, very simple application of that again theorem, tangent drawn from an external point to the circles are equal. Read the question very carefully. Prove that the angle between the two tangents drawn from an external point to a circle is supplementary to the angle subtended by the line segment joining the point of contact at the center. So this is very important to understand the problem, what we need to do here. So the angle between the two tangents is supplementary to the angle by these two lines joining the point of contact at the center of the circle. Means somewhere I need to prove this angle APB plus BOA. Supplementary means what? 180 degree. So as it is very clear from the figure, once you have drawn the figure at A and B, the angles will be of 90 degree. Why? Because the radius is always perpendicular to the tangent. These are the radius and these are the tangents here. So 90, sum of two angles is 90, so remaining two definitely will be equal to 180 degree. Why? this OAPB now is a quadrilateral, so sum of the other two angles will be equal to 180 degree. Hence, the angles at P and O are supplementary to each other. Then, before coming to question number 11, I will be discussing the answer of question number 12 with you first. Question number 12 is, a triangle ABC is drawn to circumscribe a circle of radius 4 cm such that the segments BD and DC, into which BC is divided by the point of contact D, are the lengths of 8 cm and 6 cm respectively. On behalf of this information, we need to calculate the two other sides, that is AB and AC. So, this is a figure somewhere, and triangle circumscribing a circle of radius 4 cm, here it is, and then this CD and BD are given of 6 and 8, and another two sides AB and AC I need to calculate. So what you can do here is, in this triangle you can join this O with A, then with C, and then with B. So if you get in somewhere OCA triangle, COB triangle, and AOB triangle, and as these AC, CB and AB will become the tangents at D, E and F respectively, so O to F is the radius, and radius is perpendicular to the tangent. So radius is given 4 here, 4 here and 4 here. That's why I drawn the sign of 90 degree, because all these three are the radii, and I need these in my solution somewhere, so you just can complete the figure like this. Now C to D will be equal to C to F. C is the point outside the circle, CD and CF are the tangent. So if this is 6, so this will also be 6. Similarly, DB is 8, so from B to E is also equal to B to D, so this will also be equal to 8. Now AE is also equal to AF, but this is not known to me, so I will mark that as X, so this will also be equal to X. In that sense, what I am getting, somewhere I will be reaching here. This is the triangle ABC, in which the the length of AB and AC I will be getting 6 plus X and 8 plus X, and BC total is 14 there. And now with this information, when three sides are there, in terms of X, if I need to calculate the area of this triangle, scalene triangle is there right now, so I can use the Heron's formula which you did in class 9, and for that you know the procedure. First of all, you have to find the S, and for that we can calculate semi-perimeter, that is S first. You know the procedure how to go for that, and then use the formula, that is area is equal to S into S minus A, S minus B, S minus C, and go under the root. Put the values, do the calculations, you will be reaching somewhere A is equal to X plus 14 into 8 into 6 into X, and finally somewhere you will be reaching 48X into X plus 14 whole under the root. Mark that number 1. Now, another way to find the area of the same triangle is, there is a point in the interior of this triangle, so we can join OA, OB and OC. In that way, this whole triangle ABC is getting divided into three triangles, AOB, BOC and AOC, in which the bases are AB, BC and AC respectively, and heights are OF, OD and OE of those respective sides. Why? Because radius I told is perpendicular to the tangent. So in that way, if I will be adding these three areas, I will be reaching is equal to area of triangle ABC. Then apply the formula half into base into height, half into base into height, half into base into height with respect to these three triangles. Again do the calculation. So somewhere you will be reaching at 4x plus 56. So 4 you can take out. So you will be getting A is equal to 4 into x plus 14. So that is the result number 2. So now just hold on. I will take you to the another class to cover the question on the another blackboard. 1 and 2, that is your result number 1, and result number 2 was this 48x into 14 plus x is equal to 4 into 14 plus x. To get the square root solved, you can go for the squaring both the sides. You will be getting 48x into 14 plus x is equal to 4 into 14 plus x whole square. So in that way, the square of 4 is 16 and square of 14 plus x is 14 plus x whole square. do not expand it, as already 14 plus x is lying in that side. So you can write like 14 plus x into 14 plus x, so that 114 plus x directly can be cancelled with 14 plus x. Here it is 16, here it is 48x. So 16 3s are 48x. 16 3s are 48, so you will be getting 3x is equal to 14 plus x will give you the value of x. So that you can substitute here in these two sides to get the length of AB as well as of AC. So that is a solution for your question number 12. Then question number 11. Now you just can repeat the question number 8. In question number 8 it was given that the quadrilateral is circumscribing a circle. So the difference between the question number 8 and 11 only and only is that here the quadrilateral is given a parallelogram. So up to this result, which we already have proved in question number 8, in my previous lecture I explained that to you, you have to repeat the same procedure, that is AB plus CD is equal to AD plus BC. Now as ABCD is a parallelogram, so you have reached here, you can replace this CD by AB or here this BC by AD. Why? Because we know that opposite sides of the parallelogram are equal and that will make the difference only. So I will be getting AB is equal to AD, that is what I did. I have proved the adjacent sides of this parallelogram are equal. So AB is equal to AD. Once you have proved the adjacent sides of parallelogram are equal, then we can call that is a rhombus which we need to prove. So these 3-4 steps you need to add in question number 8 solution. So you will be getting the solution of your question number 11. Then last question of your this exercise is your question number 13. The question is prove that the opposite sides of a quadrilateral circumscribing a circle subtends supplementary angles at the center of the circle. So here is a quadrilateral A, B, C, D, which is circumscribing a circle and the center of the circle somewhere is O. So O is here. I can just make you understand here. When you are joining O with A, B, C and D, so please do not take these points like AOC and DOB are collinear, because nowhere it is mentioned that AC and BD are the diagonals. Until unless it is not given, you just cannot consider that the diagonal. So join this OA and OB, so in that way you are getting one triangle AOB, and here OD with OC you are getting another triangle DOC also. Now what I did, onwards A to D, that is in anti-clockwise direction, I marked the angles here 1, 2, 3, 4, 5, 6, 7, 8, and at the center here it is 9, here it is 10, 11 and 12. So better to give the numbers, but it is up to you only. If you don't want to give, okay, no need. So what is given? ABC is a quadrilateral which circumscribes a circle with center O. What you need to prove, the line joining the center makes equal angle with the opposite sides of that. So here O is making an angle with the opposite side, that is DOC, and here AB is making an angle with O is AOB. That is 9 plus 10 means AOB plus DOC I need to prove is equal to 180 degree. Similarly 11 plus 12 also, that is AD and BC are also the opposite sides. So 11 plus 12 also can be proved as equal to 180 degree. So let us study these triangles. In triangle ODC, that is this triangle ODC, if you study this triangle there are 3 angles, 7, 6 and 9. So write that triangle angle sum property, 7 plus 6 plus 9 is equal to 180 degree. Similarly opposite to that the side is AB. So AOB triangle, if you see there are 3 angles again, 2 plus 10 plus 3. So sum of these 3 angles will also be equal to 180 degrees. So in that way we are getting these two equations by using the triangle angle sum property, and now you add this 1 and 2. So in left hand side sum of all these angles is equal to 360 degree. Now again the question in the topic of circles. So what I can do is, as this angle 7. So angle 7 is somewhere here. What you did in that theorem, the line joining the center is equally inclined. So we know that 7 and 8 are the equal angles. So I can say that 7 is half of D. Similarly 6 is half of C. And 3 is half of B. 2 is half of A. So that I did. wherever it was 7, 6, 3 and 2, so I have replaced by half of D, half of C, half of A, half of B, and 9 and 10 I need, so those two angles I have written as it is, 9 and 10. So then in these four angles, half I can take common, so inside the bracket I will be left with A plus B plus C plus D, and plus 9 plus 10 is equal to 360 degree. Sum of the angles of a quadrilateral is 360, so half into 360 will give you 180 plus 9 plus 10, and that will take you directly to prove 9 plus 10 is equal to 180 degree, that is angle COD plus angle AOB is equal to 180 degree. Similarly, if you will be applying this to this AOD and VOC, again you can prove that is equal to 11 plus 12, 180 degree. So that is the solution of your question number 13. So last year this question was the part of your section D. Same question was picked up and section D it was asked. So that's all about your topic tangent to the circles. And now some assignment questions and we keep on writing from the understanding point of view and application point of view, and then by the coming days we will shift to start with another exercise, that is the constructions related to circles. Thank you.